going to look to see what happens when we don't have nice right angles to work with. Sometimes you have to break down and use the law of cosines or even the law of sines. Now, suppose I have an engine and it's got a 7-inch connecting rod fastened to a crank, and the crank is 3 inches long. If the crank rotates in a counterclockwise circle at a constant rate of 200 revolutions per minute, I want to find the velocity, so I want dx dt, when the piston is at theta is pi over 3. Now, let's see. The first thing we want to do is realize that 2 pi radians is 1 revolution. That way I can go and convert d theta dt. If I'm moving at a rotation of 200 revolutions per minute, first thing I have to do is put it in radians. So 1 revolution is 2 pi radians. So I know that d theta dt is a constant 400 pi radians per minute. And I'm going to use this in a minute. Now, I know from the law of cosines, if this is A and this is B and this is C, the law of cosine says that B squared is equal to A squared plus C squared minus 2AC cosine theta. And you can always remember this because B is right across from the angle. All right, now, let me plug in what my values are. This is 7 squared is 3 squared plus x squared minus 2, a is 3, c is x, cosine of theta. Now, the first thing, let me find out what x is going to be at pi over 3. At pi over 3, I know 49 is equal to 9 minus x squared, or excuse me, plus x squared, minus 6x times cosine of pi over 3. So I wind up with a quadratic. If I rearrange this is just 0 as x squared minus 3x minus 40. So this becomes, x minus 8 times x plus 5. And I'm only worried about the positive one, so x equals 8 is what I'm concerned about. In real physical applications, you really only want the positive answer. All right, so let me go back to my implicit, this formula right here, my law of cosine. So this is 49 is 9 plus x squared minus 6x cosine theta. And I'm going to do implicit differentiation on this whole thing. So this is 0 plus 2x dx dt minus 6. Now we need to do the product rule on this. So this becomes minus x sine theta d theta dt plus cosine theta d theta dt. All right. Let me solve this. I'm looking for dx dt. That's what I'm looking for. So that's what I'm going to solve for. So I have a dx dt here, and this should be an x, not a theta. I knew I messed up. All right, so dx dt times 6 cosine theta minus 2x is equal to 6x sine theta. All right, d theta dt. That's not really easy to read. So I wind up with dx dt is equal to 6x sine theta divided by 6 cos theta minus 2x. And all of this is times d theta dt. Now, when theta is equal to pi over 3, I know that x is 8, so I can go and plug those in. Dx dt is equal to 6 times 8 sine of pi over 3 divided by 6 cosine pi over 3 minus 2 times 8 times d theta dt. And I know d theta dt is 400 pi because I just did that. So this whole mess is going to be, let's see, sine of pi over 3 is square root of 3 over t, so 6 times 8, this is 9,600 pi square root of 3 divided by 6 cosine pi over 6. So this is 1/2 minus 16. So it's minus 13. All right, you can actually leave it like this, or you can tell me that it's about negative 4.018 inches per minute. The negative sign just tells me that the distance is decreasing. Now give this one a go. Don't panic. Just apply the law of cosines to our Ferris wheel.